Hi YouTube, Timothy Unkert here, and in this video I'm going to explain how to use the quadratic formula. So the steps are as follows. 1. Make sure one side of the equation is equal to 0. Once you do that, you want to line up your equation so it's in the form ax squared plus bx plus c equals 0, where a, b, and c are some numbers. Then you want to identify a, b, and c. After that, you want to plug a, b, and c into the quadratic formula, which I have below, and simplify. Again, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. With that in mind, let's get to some examples. Okay, in example 1, we're going to use the quadratic formula to find the solutions to the equation below, which is 4x squared minus 7x equals 11. Now, the first step is to make sure that one side of the equation equals 0. So what we're going to do is we're going to get rid of this 11 by subtracting 11 from both sides. Now 11 is not like negative 7x or 4x squared, so we can't combine it. On the right hand side, these will effectively cancel out. You'll get one side equal to 0, which is what we want. And on this side, we've got 4x squared minus 7x minus 11. Now we've got it in the form ax squared plus bx plus c equals 0. So a in this case is 4, b is negative 7, and c is negative 11. So now we can start plugging into the quadratic formula. So x equals negative b. So whatever the sign of b is, we're going to change it. So it's going to be 7 plus or minus the square root of b squared, so negative 7 squared, minus 4 times 4 times negative 11. Now we have a negative 4 or minus 4 times positive 4 times negative 11. So really we're going to add whatever this number is here. Okay, and this is all going to be all over 2a, so 2 times 4. So let's continue to now simplify this. Okay, so we've got x equals 7 plus or minus the square root of negative 7 squared, which is positive 49. And then we're going to do 4 times 4 is 16 times 11. And remember, we got two negatives here, so it's going to be plus 176 all over 2 times 4, which is 8. Okay, so if we move up here and continue to simplify, we've got x equals 7 plus or minus the square root of 49 plus 176 is 225. All over 8. So now we've got to take the square root of 225, which is 15. So we've got x equals 7 plus or minus 15 over 8. So what the plus or minus means is that there are actually two solutions to this. So we have 7 plus 15 over 8 and 7 minus 15 over 8. So we're going to figure out what those are, and then I'm going to show you on Desmos what that looks like on a graph. So we've got x equals 7 plus 15 over the square root of 8. 7 plus 15 is 22 over 8. And if we divided 22 by 8, we would get 2.75. So we got 2.75. And then we've also got x equals 7 minus 15 over 8. So that's negative 8 over 8. So that's negative 1. So we have two solutions here, and these two solutions represent the x values on the x-axis where this parabola will cross the x-axis. And let's jump to Desmos, and I'll show you what that looks like. And then when we jump to Desmos, we're going to take, circle this, we're going to take this, and instead of setting this equal to 0, we're going to set it equal to y. All right, let's jump to Desmos. Okay, I'm on Desmos here, and I just got to Desmos by searching for Desmos graphing. And what we're going to do is we're going to set y equal to this 4x squared minus 7x minus 11. Okay, and now I'm going to show you if we go along here and we see the first place this parabola crosses the x-axis is at negative 1, 0. So remember that x value, one of the x values we solved for was equal to negative 1. The other spot it crosses is at 2.750. So the other one we solved for was x equals 2.75. So those two solutions that we came up with were the two spots where the parabola crosses the x-axis. Okay, we've got this next example here. It says, use the quadratic formula to find the solution or solutions to the following equation. So our very first step is we have to move that 2 over to the left-hand side so we can get one side equal to 0. So I'm going to subtract 2 from both sides. Okay, so 2 minus 2 is 0. And then we can't subtract 2 from minus 7x or 3x squared. Those are not like terms. So we're going to write this as 3x squared minus 7x minus 2 equals 0. Okay, so we've got it in the form ax squared plus bx plus c equals 0. We've got to identify a, b, and c. So a is equal to 3. B is equal to negative 7. And C is equal to negative 2. Okay, from here, let's plug into the quadratic formula. So I'm going to say x equals negative b, so the opposite sign of b, so positive 7, plus or minus the square root of negative 7 squared minus 4 times 3 times c, which is negative 2. And that's all over 2a, so 2 times 3. Okay, so if we continue this, we get x equals 7 plus or minus, well, negative 7 squared is positive 49. And then we have a minus here, but we also have a minus here. So really it's 4 times 3 times 2 is 24. And because we have two minuses or two negatives, we're going to have plus 24. And 2 times 3 is 6. So I got 6 here. If I add 49 plus 24, I get 73. So I got x equals 7 plus or minus square root of 73. And the square root of 73 we really can't simplify over 6. So our two solutions are x equals 7 plus square root of 73 over 6, and x equals 7 minus the square root of 73 over 6. Now, if we're going to estimate the square root of 73, well, the square root of 64 is 8, and the square root of 81 is 9, so it's somewhere between 8 and 9. So this is like 7 plus 8.5, roughly. I mean, so it's like, I'm approximating, of course. So it's like 15.5, roughly, over 6. So 6 goes into 15 twice, and then maybe another, maybe 2.4, 2.5, something like that. And then this one, 7 minus the square root of 73, so 7 minus 8.5, so it's like, kind of like negative 1.5 over 6, so it's, approximately negative 1/4, around there. It's not going to be exact, right? Or negative 0.25, not going to be exact. So what we're going to do is we're going to take this here, and we're going to check out where these solutions are. We're going to set this equal to y. So I'm going to say y equals this. Okay, so let's jump to Desmos. Okay, so we're at Desmos, and let's plug in y equals 3x squared minus 7x minus 2. And we see that, yeah, we're very close to negative 1/4. We're at negative 0.257 for one of our x values. And then the other one is at, 2.59, I guess at 2.4. So I was a little underestimating it there. But yeah, so we have demonstrated again with the quadratic formula, we can find these spots where the parabola crosses the x-axis, even if our solutions look a little bit messy with those square roots and so on. Okay, in our third example, we're going to use the quadratic formula to find the solution or solutions to the following equation. So we have negative 7x squared plus 11x minus 3 equals 0. Now, we already have the equation set equal to 0, so we've got a little bit of a head start. We also have the equation set up in the form ax squared plus bx plus c equals 0. So let's start by identifying a, b, and c. So a equals minus 7. B equals 11. And C equals negative 3. And let's plug these into the quadratic formula. So I'm going to say x equals, well, negative b, so negative 11 plus or minus the square root of 11 squared minus 4 times negative 7 times negative 3. And this is all over 2 times negative 7. So if we continue to simplify this, we get x equals negative 11 plus or minus the square root, well, 11 squared is 121. And we're subtracting, but we have 2 minuses here, so these are going to multiply to be a positive, so we're actually going to be subtracting whatever this is. So 4 times 7 is 28, and then times 3, so let's work this out. 3 times 8 is 24. 3 times 2 is 6, plus 2 is 84. So we're going to subtract 84. And 2 times negative 7 is negative 14. All right, so if we go up here, continue to simplify, we get x equals negative 11 plus or minus, well, 121 minus 84 is, let's see, so we got 21 plus 16 is 37. So square root of 37, that one we really can't simplify that much. over negative 14. Now we have a negative over a negative, so really we could just say 11 over 14. And technically it would be minus plus, but plus minus minus plus, whatever. So I'm just going to write this as x equals 11. Well, we have a plus, square root of 37 over 14. And x equals 11 minus square root of 37 over 14. So square root of 37 is very close to 6. So this is basically like 11 plus 6. So 17 over 14. That's like, yeah, 1.3, something like that. Okay. And then this is like 11 minus 6, so this is 5, so it's a little less than half. So let's say about 0.4. Um, so now let's jump to Desmos and see how close I was with my estimates here. All right, so we're at Desmos, so I'm going to enter in the equation y equals negative 7x squared uh, plus 11x minus 3. Okay, and so we've got, yeah, about 0.4 and, yeah, a little under 1.3. So the estimate was on, and again, with the quadratic formula, we come out, we can figure out where the parabola is crossing the x-axis. Okay, in our last example in this video, we're going to use the quadratic formula to find the solution or solutions to the following equation. X squared equals 2x minus 9. So I want one side equal to 0, so I need to subtract 2x from both sides. And I also need to add 9 to both sides. Okay, so when I do that, 2x minus 2x is 0, negative 9 plus 9 is 0, so the right-hand side becomes 0. Then I have x squared. I can't combine it with either of these, so I'm going to write x squared minus 2x plus 9 and set it equal to 0. And now I've got it in the form ax squared plus bx plus c equals 0. Now it's understood there's a 1 in front of here, so that's going to be my a value. A is 1. B is negative 2. And C is 9. So we're going to use the quadratic formula. So it's x equals whatever the opposite of this sign is. So negative b, which would be 2, plus or minus the square root of negative 2 squared minus 4 times 1 times 9. And this is all over 2 times 1. So this is going to be x equals 2 plus or minus the square root. Well, negative 2 squared is positive 4. And we have 4 times 1 times 9, that's 36. So we have 4 minus 36. So that means what's under the square root, which is called the discriminant, is going to be negative, which means we're going to have two complex solutions. And I'll show you what that means graphically in a moment. Okay, so then the bottom is 2 times 1. So if I come up here, we get, and we simplify further, we get x equals 2 plus or minus 4 minus 36 is negative 32 over 2. Now I can simplify this. So I can say x equals 2 plus or minus, and then we can break this apart to -1 times 16 times 2. And the reason I'm doing this is, well, the square root of -1 is in mathematics equal to I, because there is no number that you can multiply by itself to get -1. Think about it. If you multiply a negative times a negative, you get a positive. If you multiply a positive times a positive, you also get a positive. So there's no way we can multiply anything to get -1. So it's imaginary. But interestingly enough, complex and imaginary numbers are used in real life, um, which is kind of cool. Okay, so this is going to be I when we come outside. So we're going to bring this outside, and this is going to become I. Likewise, we could take the square root of 16. When we bring it out of the square root, it's going to be 4. So we're going to have 4I. We'll get rid of these, and we're going to just be left with the square root of 2 under here. So if I want to rewrite this, I've now got x equals 2 plus or minus 4I times the square root of 2 divided by 2. Now, 2 divided by 2 is 1, so we can simplify this further, and we can say x equals 1 plus or minus, and we have all this multiplied together. We can't take 2 and divide 2 into the square root. That's not the same thing, but we can take the 4 divided by 2, and we get 2I square roots of 2. And you may be thinking, okay, well, what does that mean? We have one solution, 1 plus 2I square roots of 2. And then the other solution is 1 minus 2I square roots of 2. So these are complex solutions. They're not real solutions. And what this means is this parabola, this quadratic, when it's graphed, it's never going to cross the x-axis. And I'll demonstrate that in a minute on Desmos. So what we're going to do is we're going to take this, and I don't have to write the 1. So I'm just going to take x squared minus 2x plus 9. We're going to say y equals this. This is going to be the equation we plug into Desmos. And then we're going to look, and we're going to see that it's not going to cross the x-axis. Okay, I'm at Desmos, so let's plug in this equation. So it's y equals x squared minus 2x plus 9. And we don't seem to see the graph, but if I zoom out, you notice, oh, here's the graph. It's kind of up here, and it never crosses the horizontal x-axis here, just like I said. So again, when you get complex solutions using the quadratic formula, you know that your quadratic is never going to cross the x-axis. Anyways, so that's the quadratic formula for you. If you enjoyed this video and if you want me to derive the quadratic formula, comment in the comments below. Also, if you like this video and you haven't subscribed yet, please subscribe, and also consider liking the video as it helps push it out to more people so more people can learn about the quadratic formula. Thanks for watching, and I hope to see you in the next one.